Hello and welcome to the PACP preview presentation. The online PACP presentations were reviewed in part by the following industry professionals. NASSCO would like to acknowledge their efforts. The Pipeline Assessment and Certification Program is an internationally accepted standard for recording pipeline defects and observations. The PACP defects and observations are organized into the following families: structural defects, operational and maintenance defects, construction features, and miscellaneous features. The PACP program was developed with the assistance of the Water Research Center. The WRC codes were modified to better address special conditions within the U.S. A committee was created for this purpose. The committee's first meeting was held in June of 2001, and the final meeting was actually held on September 11, 2001. Based on the outcomes of the committee, the first PACP class was taught in January of 2002 in Virginia Beach. Reasons for TV inspection. There are many reasons for TV inspections. The following are the ones available within the PACP program: maintenance-related activities, inflow and infiltration investigations, post-rehabilitation surveys, pre-rehabilitation surveys, pre-acceptance jobs, routine assessment, or is often called proactive maintenance, capital improvement projects, resurveys for any reason, and reversals. There are often many circumstances that prevent an adequate inspection. Let's review some of those. When possible, inspection should be performed in a manner that provides an unobstructed view of the entire pipe area. Debris or other obstacles should be removed. Not being able to complete an inspection is a common problem. Pipeline segments should be inspected entirely. Often the portion not inspected is the most problematic one. To avoid visual misconceptions of defects, the camera should be moved through the pipe at a steady pace not to exceed 30 feet per minute, or 9 meters per minute. New pipe scanning technologies may allow for faster camera movement. Image distortion is a common problem when the camera is not properly centered. Also, excessive lighting is another common issue in light color materials. It's also common in overly adjusted camera iris. The loss of pipe support is represented in 3 sequential stages. In the first stage, the pipe has cracks or fractures, but the pipe remains stable, supported and held in position by the surrounding soil. In the second stage, some soil particles surrounding the pipe have washed into the pipe. This is caused by a respiration effect that's caused by infiltration and exfiltration of water. In this stage, side support is lost, allowing deformation of the pipe. Due to the progressive loss of support in the third stage, the pipe crown drops, and the likelihood of a pipe collapse increases significantly. Depending on the type of surrounding soil, the groundwater level, and other factors, the time between these stages will vary. Hydrogen sulfide attack in pipelines is represented in 2 sequential stages. Sulfides are generated under the absence of oxygen within a pipe. This is a condition we call anaerobic. Force mains generally flow full with little aeration and are likely points for sulfide generation. Sulfide is also generated in flat gravity sewers with very laminar flow, which allows anaerobic conditions at the bottom of the pipe. Sulfides in the wastewater are released by turbulent conditions at discharge points into the air and form hydrogen sulfide gas, or H2S. This acidic gas attacks concrete and metal surfaces. Because hydrogen sulfide is heavier than air, the deterioration usually starts low or at the flow line. Root growth. Due to the less consolidated nature of the pipe surrounding soil in trenches, roots always tend to grow towards pipelines. When roots reach the pipe structure, they expand and intrude through the points of least resistance, which are often defects in the pipe. The infiltration and exfiltration of water puts fertilizer in the surrounding soil, accelerating root growth towards the pipeline. The subsequent root growth inside the pipeline generates blockages, surcharges, and overflows. Fats, oils, and grease deposits. The accumulation of grease often produces blockages. These types of blockages can cause backups and overflows. Grease can also accelerate structural decay. Aggressive and repetitive cleaning to remove grease may induce pipe deterioration as well. A typical CCTV form includes two parts. The top portion is called the header form. The details section lies below the header form. The PACP header form requires the operator to include certain general information about the inspection and some other details about the pipe segment. It is always necessary to complete a new header form each time a new access point is reached, or if a reversal inspection is needed. The header form has both mandatory and non-mandatory fields. A total of 42 fields make up the header form. 1/3 of these fields are mandatory. Let's review which header form fields are mandatory. The mandatory fields gather minimum specific information needed to carry out an inspection. The fields shown here in red correspond to the mandatory fields. Review these fields with your manual to find out the specific requirements. The fields shown here in black represent the current non-mandatory fields. Example of these fields are Field 9, time, Field 27, lining method, Field 29, total length, or Field 37, weather. Now, as we discussed before, the CCTV inspection form is divided into two portions, the header sheet and the details section. This image shows a typical CCTV details section. Now let's review the use of each of these columns. The distance column is used to record the actual footage at the defect or observation. It is always recorded with 1 decimal accuracy. The video reference column automatically records the video counter or frame number when coding a defect or observation, unless the inspection is carried out using a VCR, in which case the video reference is entered manually. The code column is divided into two group/descriptor and modifier/severity. Although these divisions are not always shown in the software programs, in this recertification course we'll review them to better understand the nature of the PACP codes. In the continuous defect coding column, an operator can further classify those defects that appear to be uninterrupted. The value column is also divided into three main categories, the SML column, the inches column, and the percentage column. These columns are used by different codes depending on the nature of the defect. The joint column is filled with the letter J if the defect or observation is within 8 inches of a joint. The circumferential location column is useful to describe the location of the defect in cross-section, plane, or circumference. If two references are needed, mark the beginning and the end of the defect in clockwise fashion. If an image or photo is taken, a reference is automatically given and recorded here. Finally, include any other quality or comment in the remarks columns. The column is also required for some codes like AMH or access manhole. The following video shows how to code in the CCTV inspection form. In this case, the code AMH is recorded. The code MWL should follow.